we doing? I love your little thingies in your hand. It's really cute. Okay, so at small group today, we're going to be solving 3-digit by 1-digit multiplication, okay? We're working on that. From iReady, we saw that that's something we might need to be focused on and looking at, so we're going to be working on 3-digit by 1-digit multiplication. Your mastery is going to be kind of like it always is. You're going to be able to explain like why this is working, explain your problem, and show me with models, and then show me with an equation. So always equation, always with those models. So you'll have a pencil. Or do y'all normally write on, when you come to small group, do you use board markers, or do you normally use paper? It depends. Okay. Yeah, it doesn't matter. You don't think so? I probably need something to write on though.
I think Alexis.
Is she getting her whiteboard? Yeah, I need something to like write on. Okay. So, get me something to write on. Yes, you guys are gonna. I'm gonna send you some of this paper. How about that? We'll just tear some out. So remember, you're gonna be working on your equation, and you're gonna be working with partners. So I'll give you something to write on like this. Thank you. You're welcome. Okay. So what does 7? Thank you, sweetie. What does this 7 times 4 mean? We talked about it a little bit. 7 groups of 4, right? So if we were modeling this, what would that look like with a model?
It would be 2 10 rods and 8 little 1 units.
So he's saying there would be 10 rods and 8 units. What do y'all think?
2 rods.
If you were going to show, oh, I see what you're saying because it's 28. But how would you model 7 groups of 4?
Have 7 groups.
Yeah.
But 4 in each box.
So she's saying we could do 7 groups like this, and we could put 4 in each one. Would y'all agree with that? Would you agree with that? So that would be 7 groups of 4. So keeping that meaning in mind, I want you to work with your partner. You guys are going to be partners, and you guys are going to be partners, okay? And remember, our master criteria is to do this multiplication to show me with a model, and to show me with an equation, okay? And so I want to see you all solve a model for this. Ready? So what would a model look like? And you can use these blocks here, or you can use the chips, but whichever ones you want to. So remember, equation and a model. So 4 times 14. What would that look like? Talk to your partner.
And I can do So 4 times 4 equals 16. Plus 4 equals 56.
So what does this mean?
4 groups of 14.
4 groups of 14. Can you show me that with a model? What would 4 groups of 14 look like? Show me that with a model. You can use either one. Tell me what you're modeling over here. Tell me what you modeled right here. What is this? Oh, so you did 4 groups of 10. Where did you get the 10 from? Oh, so you did 4 groups of the 10. Can you show that with an equation? Remember, part of our success criteria is to show that. So I want to see where you're getting the 4 groups of 10. So what are you going to do next?
Hold up. I think I just found some.
Yeah. Got enough of them out?
Yeah, because we Can we use this too?
But tell me what you're doing here. What are you doing now?
We're doing 4 groups of 14, so I'm going to put 14 rods and 4 little dots. Oh, hold up. 1, I need little dots.
Okay, you need the little singles, the ones.
Yeah,
Okay, let's let them. They're always at the bottom, aren't they? There they come. So now what are you making? 4 groups of what?
14.
Okay. So you can help. You can make one. So she's making a group of 14. So how many groups are you going to have?
4 because there's 4 multiplied by.
Okay. So what is your equation going to look like to show how you solve this? How are you going to figure out the total product?
We can just do 4 times 14.
Okay.
So we can do 4 times 4 first. So that
Oh,
would
can you show that with an equation?
yeah.
show that how you did 4 times 4 so we see that?
So-
Here's the real problem. The first year saying you did 4 times 4, right?
All these would equal
Can
16.
you show that with an equation?
But then you had the regroup for a 10.
Well, here, let's put those in your 4 groups of 4 like you had them. So when you put those together, you get, so can you write, what does this right here look like? Can you help her write that equation? Yeah, I like that. And then how many?
14. So 14.
Oh, nice. Okay, so tell me about your, what is this?
And then,
Where did you get this
so
10?
then there's 16. So then we would have 6, and then we would regroup that as a 10 and put one more 6 down.
Interesting.
And then, so that would be 56.
Okay.
6 was left over.
So let's look at your model. Let's talk about these 2 different models. Let's look what you got here. You ready? So look at their model here. Tell me about what did they do? What do y'all see here?
They did the same thing we did at the start, but then we just regrouped everything.
Oh, so do you see look what they have over here? They have 56. Do you have 56?
Yeah.
But that looks really different. What's he talking about? What did he do when he says he's regrouping? What did he do? Is that what you did? And then what happened? Ah, fair traded them out, just like equivalent fractions, right? We had equivalent, make an equivalent one. 56. So you were able to do that too. Did you have to do that? So look at their equation. Look at this equation. Where'd they get this 40?
They did 4 times 10.
Oh, so where'd the 10 come from?
4.
So they had to decompose this 14 into a 10 and a, whoops, slow this camera right upside down, a 4. And so show me, they did what first?
10 times 4.
Okay, so they did 4 times 10, that's there, and then they did 4 times 4, that's there, and they got 56. So in their equation, they're showing that partial products there. And that partial products equation is very helpful in solving the problem, right? So you all both kind of use the same strategy. First you made 4 groups of 14, right? And then you all multiplied the 10s by 4 and the 1s by 4. You all just kind of added them all together. Can you add all these together to get the product?
Yeah.
Yeah, because multiplication is what?
Adding or
It's
dividing.
repeated addition, right? So let's talk about another problem. Thinking the same process of modeling and then writing the equation, let's do a different problem. Are you ready? Okay, so here's your new problem.
Okay, so
232 times 5. You can use the blocks or you can use the chips, whatever you want to do. But talk to your partner about, remember your success criteria is that you're doing a model and an equation.
that would
We've
be
got about 3 minutes.
32. This would be 232.
Would you agree with that? So what are you going to do now, do you think?
We're gonna put. It has to do 5 groups of this. So
Now hang on a minute. You're saying you need to do 5 groups of this? I thought this was 232 groups of 5. You're only going to do 5 groups?
yeah, because 5 times you have to do your amount. Because we already got our setup, and then we have to do 5 times everything.
Oh, so you're going to flip it and say 5 groups of 232. Why wouldn't you do 232 groups of 5?
It doesn't matter. It doesn't matter. Really.
Doesn't matter. She said it wouldn't work. Would it work?
Yeah, it would because it doesn't really matter.
Will that take a long time to do 232 groups of 5? Yes, it's a little more efficient, like we talked about with number talks, to make 5 groups of this. So keep going.
It doesn't matter
What about you guys? What's happening over here?
So,
Oh, tell me, what does she mean by she's doing partial products?
so let's do this because then we would have to add 5. So 10. So this would be
Decomposing the number,
right. 1, 2, 3, 4,
making 5 groups of each. Nice. So, do you want to try it with the chips?
and then we would have to
While he's working on it,
5
do you
times
want to try
3
it?
equals 15.
What would that look like?
That would be
Would it be
16.
different?
And then we'll have 6
Would it
groups
be,
of
would you
us,
still be
and then
doing
we'll add
5 groups of
We'll do
200? Can you
5
show me
times
5 groups of
10,000
200?
plus 10,100.
With the chips? What would that look
Get
like?
what I mean?
And 5 groups of 30?
11,003.
Don't forget, part of your success criteria is to write an equation. So think about what you're doing here.
11,600.
So where's your model? Your 232 went away. What happened to it?
Because 5 times 2 is 10, so you would have to regroup it. And then.
Okay, but 5 times 2 what? 2 hundreds or 2 ones? Oh, 2 ones.
Yeah.
Okay, so you did 5 groups of 2 ones. Is that what I'm hearing you say? Okay, so you made a 10. Okay, great.
And then, but you have to.
Can you show that? Can you say 5 groups of 2 ones like you did? And you don't have to draw the circles. You can just write the equation 5 times 2.
And then you have to do your 30 times 15. So and then, like, since you have a regroup, you have to regroup. You would have 16, but you have to regroup it because you can't have two numbers.
So this is 232. How many groups of 232 do you need? 5. So can you make 5 groups of that? You have 5 groups of 200. You need 5 groups of what? Here, so you have your 200 to your model in your equation. 200 groups of 5. I said that wrong. 5 groups of 200. Now you need to do what? Exactly. And then what's she going to also need over here?
Okay, we'll just get 10 to
5 groups of.
We're getting 10 to thousands from here because we don't want to use all that. So we'll have 10 to thousands.
Oh, I see what you're saying. Yeah.
Because he has to have one. So we're getting 10,000. And we'll have 100. Yeah.
Okay. So you got yours? If they need to start, where is she? If they need to start cleaning up their stations, I don't know if they go somewhere or whatever they can, because we're almost done over here. Okay, so let's look at these 2 models. Look at this, guys. What do you notice about their model here? What do they have?
Groups of 5.
5 groups of what?
10. 230.
Hey, why didn't y'all do 232 groups of 5? That'd be a long time being here, right? Could you do that?
Yeah.
Would you get the same answer?
Yeah.
Yeah, it's just going to take you a lot longer, right? So you said you see her 5 groups of 232.
Yeah.
Look at their equation. Where do you see this? Where do you see that? In their model. Where do you see that? She said 200 times 5. Do you see 200 times 5? Where is it?
It's right here. But
200 groups of 5. Or, I said it wrong again, 5 groups of 200. Right? And how much was 5 groups of 200?
that's go with 1,000.
Can you write that in there for us? It's 1,000, right? Would y'all agree?
Yeah.
So then where do you see this?
That's 15.
5 groups of? How much is 5 groups of 30? How'd you figure that out? How'd you figure that out so quickly? How'd you know that? So 3 groups of 5 ones would be 15. So 3 groups of 5, or 5 groups of 3 tens. Do we have 5 groups of 3 tens? Is 15 tens. Would you agree there's 15 tens here? Which is 150. Then we have our 2 groups. So they have their partial products again. So their total product, you guys came up with it as well. Look at what they have. 1,000, 160. Did you all get the same answer? How'd they get all this? What do you think they did? What was their strategy?
We did 2.
Look at it. What do you think they were doing? You guys have all of your 232s modeled. Where are all their 232s? Is that what you did? He said you took away these and made a what? 1,000. Then you put all these together and you took out the 100 and then you gave 50 here and then you had your 10. So what do you call that?
I got 660 here because you had to do 2 times 5 equals 10.
Right.
And then you got that.
Excellent. So you see their partial products here? That's one thing I want you all to work on when you come back to group, okay? You're doing an excellent job of modeling. I love your models. We want to work on our writing it with partial products, okay? Just a nice job of meeting your criteria there, of doing an equation and a model, okay? Thanks, guys. I hope you have a great rest of your day. If you stuff those back in there, that'd be great. And Miss Winters, we're done. question, so I'm not sure what you need to do next. But thank you guys. You're precious. I really appreciate your here, and I'll keep those if you don't mind. Thank you, sweetie.